Hi everyone, welcome back. Lastly, we learned about this PCA optical flow, and today we are gonna learn the last one, which is variational refinement. Actually, as we did in the previous videos, we are just gonna focus on to the usage of this variational refinement. Also, we are gonna check the properties, and in the next video, we are gonna focus to the member functions as we did before. And with this one, we are gonna finish this dense optical flow. We already checked all the classes inside, and I also completed our table. Until this part we already checked, and also you can stop the video and check the details of this table. And this variational refinement is only improving the result of the other flow algorithms. In here you see, for example, you are using TVL1 method and you are not really happy with the results, you just want to improve. Okay, TVL1 for example is the best choice between these 5 class, and you want to continue with this one, but you want to get little better results. So in that case, at the output of the flow output, you can apply one more variational refinement, and it's gonna try to improve the results better. Of course, the only disadvantage is this is gonna be computationally expensive, because you already apply this, and you are also applying this variational refinement. So you can check the table detail later, and we can switch to the code part. Actually, this is the code from the previous video. We are just applying PCA flow. As I said, we need to for example, where I'm applying, okay, this one here is I'm applying. So this output I need to use for the variational refinement, but for just checking to be sure, I just want to copy this one and temporarily comment out, and so we can directly call our variational refinement, so we can check it is not gonna work like the others. So we can create, and this is done. And we are as we did for the other classes, we can just try to apply this optical flow like others, and we can try to run the code, and we are gonna see. I think I'm just continue. Okay, it crashed because actually it says the flow is empty, so this flow shouldn't be empty, so it can enter to the algorithm. So it expects this flow should be always should be always not empty. So in this case, this can stay. We can open this comment out. So for this video I want to use PCA flow. You can try for other methods also. So but before this one, maybe we can try to see the results of the PCA in the right side for the example, and we can compare each other later. This is gonna be my PCA. I think it's working. Okay, and now I want to create variational refinement optical flow. Maybe we can just write variational optical flow, and also we created 2 optical flow now, and this variational refinement should be applied after the PCA flow. And here we are just calling the calculate function one more time, and here all we need to do is just calling the same, and also flow can be same, because so now this flow is not gonna be empty and it's gonna work. So but at the end, it's not gonna actually directly use the flow output of this PCA flow. It's gonna use the flow of which is gonna be the output of the variational refinement class. So it's gonna use that in here. Okay, now we already applied. Now my expectation is gonna work fine, and we can compare the results with normal PCA flow and the new one. Okay, the right side is the normal PCA flow, and the left side is just applied, which is variational refinement. So we can continue, and step by step we can check. Okay, for example, in this moment we can come. There's only one motion vector. Oh, sorry, I missed that in the left side. So we can just try to see here. Okay, here I see 2. In the left side I couldn't see, so I want to check again. Rerun. Okay, this is the, I started again. I want to see one more time this moment. Okay, so both sides for me now same, nothing changed. Maybe we can continue a little more. This is also a bet. I think in the right side also PCA is also giving bad results, I believe. Yeah, it's like that. We can check in a good scene. Okay, maybe this one. Let's come to that moment. Okay, here for example, in both sides these motion vectors, by the way, if only this one there is nothing output, if like this something, it means there is a motion vector here, and here I see the same thing in here. In the below side this is same, but this one PCA, just to remind, and here you see there is a motion vector, even small, but in here is subtracted, so it's declined, it cancelled. So also in here also same, for example, the coordinate, you can check x and y here. This coordinate is 416 and 96, and the same coordinate, and in this scene it's removed. So okay, maybe in the previous cases, since the PCA is not giving good results, it cannot remove all the noise, but for this scene we see these are removed, and this is I see removed, this is removed. So some noisy places, I think for this moment at least, it removed the correct wrong motion vector successfully, I can say. And maybe we can check one more moment. Okay, here there is many noise. Let's see what it's doing in here. Okay, if many noise, maybe not working very well, or even in this size maybe it's little improving, but I didn't see clearly. Let's for this ball there is a motion vector, it's just changed little the direction and didn't play much around. And let's see one more. Here also there is many motion vectors. Okay, for the white one maybe we can check one more time. Here maybe there are many again. Okay, here for example the last one is in the y-axis 111, and here also it still exists. It didn't remove very well, at least I see, maybe in a more simple way. Okay, there are many noises I see. Yeah, but at least for one moment we see it's subtracting, it's trying to remove the noise. At least we see in that moment. It means I think for just trying we understood how it's working. Of course in the next video we are gonna play with the parameters, and maybe we can play around more detail. And I'm done for this video. Thanks for watching. See you in the next videos.